Soon we're going to start creating a player controller so we can move our player around and jump and do other actions. So before we start that, we just need to cover some basics of what are called vectors. Now vectors can become a very complex topic. There's a lot that can be done with them, but they can also be very simple. So to start off this course, we're just going to cover what we need to know, and you'll learn and progress as we go further. Now a vector can store a few different things. We can store a position in a vector. So if we look at our player right now and we look at the transform, we have a position here. So we have an X, Y, and a Z value. These three values together are what's called a vector 3. And the 3 just mentions how many different axes there are. So in 3D, you're going to have 3. And then we also can use a vector 2, which is for 2D, where it only has an X and a Y value. So in our case here for our game, even though we do have an X, Y, and a Z in the transform, because we're working in 2D, everything on the Z is always going to be 0. So we can just use a vector 2, even though this is technically a vector 3, and everything is going to work fine. Because when we add an X and a Y, all it's going to do is it's going to change these values and ignore the third one completely. That is at least one thing that makes it a bit easier for us to get in as opposed to being in 3D to start with. So now I mentioned it can be a position like this, but a vector can also be a direction. So just to first look at the position, if we were to move our player up somewhere, say up here, so let's just put whole numbers, so 6 and 5. That means our player is now at position 6 and 5. So if we were to assign this in code in a vector, we would add 6 and 5 to our vector. And then if we moved it down, I can just turn snapping on. And now when I move the player, it's going to snap on grid spaces. So say if we had the player here, we would now be at position -3 and 2, which is another vector. Then the other thing we can do with vectors is we can add a direction. So if we wanted to use a vector that said go to the right or move to the right, we would add a vector that has a positive number in the X. And what that means is it's pointing or moving this way to the right. And then the opposite's true as well. If we put a vector with a negative number in the X, it would mean go this way. And then the same works for the Y. So a positive number would tell an object to move up, and a negative number would tell it to move down. So those are very simple terms, but we just wanted to get started with that. And then as we progress, I'll explain more so you start getting a better understanding of that. But to demonstrate this, let's go on our player with our player selected. We're going to add a script to our player here. So let's go to add component. And now we can type in the name of our script. So we can put player controller. So now if I type that, this is the search box and it's trying to search for something called player controller and it doesn't find anything. So what it does is it realizes we probably want to make a new script with that name. So it gives us the option right here. We can just click on new script and now it automatically puts in the player controller name, which is perfect. So you can click create and add. So now this is another way that we could add a script to an object. So there's always the first option that we showed earlier where you can just create a script here and then drag and drop it onto your object, or we can just add it directly like we did. Okay, so we have the player controller here and we already have a scripts folder. If you didn't follow that earlier, you can just right click, create, go to folder, and then just name it scripts. So let's drag our player controller script into there. Okay, and now let's go to player. We're going to scroll down and let's double click player controller. Okay, and now that we're in the player controller script, if you remember from the C# basics section, we talked about variables and we could make different variables here. So like an integer or a float. So now there's another type of variable here. We can make a vector 2. So let's make a vector 2 and let's just we'll call it new position. Okay, so we have this variable. This is going to store a position where we want to move our player to. Now, to put something in a vector 2, we have to do it a little bit different here. So when we put equal, normally for like an integer, we would just type a number here, so something like this, or for a float, we would put a number with an F like that with a decimal. So with a vector 2, it's a little bit different. What we have to do is we have to put the keyword new to tell it we want to create a new vector 2. And then we put vector 2 again. And now we put open and close brackets or parentheses. So now what we do with this is we put the X and Y value in. So just like in the inspector, so if we go back to Unity, if we look at our player here, we can see it's currently at 0 on the X, 2 on the Y. So if we wanted to put our player in that same spot, we would put 0, 2, just like that. So now we have a variable, which is called new position, and it's storing the vector 2 inside of it of 0 and 2, which is that position. Now to move an object to a specific position, Unity makes this very easy. What we can do is we can type transform, and this is the same transform that's up here. So we're accessing this one. The only difference is this has an uppercase T. We want to use a lowercase. So we can access that, and then under it, we can access the position. So to access that, we put a dot and then position. So you can kind of think of this as the transform is kind of the high level. And then inside the transform, it contains a bunch of different objects in there. So we have position, rotation, and scale. To access any of those from transform, we have to put a period and then what we want to access. So in this case, position, but we could also do transform.rotation or transform.local scale, and that's going to be the scale size. So let's go to position, and we could say transform.position equals new position. And then we put the semicolon at the end. So now what this is going to do is when we start our game, our player is already in the scene, so it's going to run this code. Start is going to run as soon as the player is on the screen, and it's going to run this code saying transform.position equals new position. So this is going to move our player right here, and our player's already in that spot, so we have to move them out. So watch what's going to happen. Our player's here when we run the game, and it's going to instantly move to this spot. Okay, so there, now we have the player moved there. And that's how we can move a player. Now, what we can do is we can use this to increase the position that we're at or to add to it if you want to think of it like that. So let's try this. Right now we're setting transform.position equals to this new position. What if we wanted to do something a bit different? Let's go here. Our player's here right now. So we're at position -8. So -8 and 0. What if we want to just move our player over here, but we want it to always move this far? So say if our player is right on the edge here, and we want it to move 1, 2, 3 spaces to the right. So we want it to end up right here. Let's go back to our script. Let's change this. So remember, it's always X first, then Y. Let's set the X to 3, and let's set the Y to 0. So now if we're doing this, right now we're going to set the player to move to position 3 and 0. So if we run this code, notice our player moved all the way over here, and that's not what we wanted. What we can do instead, we have transform.position equals new position. So to demonstrate this, what I'm going to do is remove everything that's in start right now. We have new position, and it's got 3 on the X, 0 on the Y. So what we can do is actually add math, just like we do with integers. So let's create another variable. I'm going to create one here just called vector2. I'm going to call this current position. Okay, and I'm not going to set that to anything yet. But now inside of start, the first thing I'm going to do here is I'm going to say current position equals transform.position. So now we have the current position as a vector 2 of where our player is. So if we look at the current example, if we look here, that's going to take -9 and 0 and store it in current position. Then what we can do is let's get transform.position just like we had before, and we can set this to be equal to current position plus new position. Now I'm going to run this, and instead of seeing it jump over here, we should see the player just move 3 units to the right. And there we go. And now this is going to work regardless where we are. So if we move to this platform, now we're going to move 3 units to the right here. And then same thing up here. Okay, so that's how we start working with using vectors as a position as well as a direction. Okay, so a quick summary, just in case you have any trouble understanding this. We're making a variable a vector 2, and we're going to get the player's current position. So we put it in here. And then we assign the current position plus the new position into our player's transform.position, which, as I showed earlier, is this right here. So when we run our game, what we're actually doing, it's the same thing here as us typing in these values, except we're doing it from code. So if we're here at -1 and 2, and we wanted to move 3 to the right, that would be the same as putting in 2, just like this. So that's how we start changing these values from code. Okay, so that's it for this video, and I will see you in the next one.